Alright, here's a problem that might come up on a test. This goes back to our thermochemistry chapter. In the problem says this: use the heats of formation information provided in that table down there, and you will be given those. You'll be given a table. Let's calculate the heat of reaction for this following problem right here. So I've given you this equation, and let's calculate the heats of reaction for this. So if you're given a table and I tell you to calculate the heat of reaction giving these heats of formation right here, then this is the equation that we will use in order to do that. And it looks a little bit complicated, but it's actually quite simple. The first thing is I'm going to take the products. Don't forget to do the products first. I'm going to take the products, and then I'm going to subtract that. It's a minus that I've now obscured. I'm going to take whatever the sum of those are, that's what that sigma means, and subtract that from the sum of the reactants. Now what am I summing up? Well, N is the number of moles of that particular product in this case, times whatever I look up in the table. And I'm going to do that for all of the products. So let's just get going since I'm talking about it. And look at these two things first. Okay, so I have 2 moles of HCl. And so I'm going to say that the heat of reaction for this thing is equal to the sum of the products. Let's look at the products first. That's going to be 2. And I'm going to look up HCl gas. HCl gas is minus 92. So it's going to be 2 times minus 92. And there's one of the products. And I'm going to add, that's what that sum means. I'm going to add that to the other products here. I only have one more. I have 1 mole of H2SO4. And so it's going to be 1 times H2SO4, which is minus 814. Sorry for my bad handwriting. I'm still not good at this stupid tablet. Okay, so now I've accounted for all the products. So I'm going to add those two together, and then I'm going to subtract that from the reactants. So I'm going to go to the reactants side, and I'm going to take the first one, which is SO2Cl2, which is minus 364, and I only have 1 mole of that, so it's going to be 1 times its heat of formation, which is minus 364, plus, that sum means I got to add all the reactants. In this case there's 2 H2O liquid, so I have 2 moles of that, so it's going to be plus 2 times, in this case it's minus 286, so sorry, minus 286, and that's the math that's set up. And so we can go ahead and start calculating this through. I always go the slow way, so that's going to be 2 times minus 92, okay, 2 times negative 92, and so that gives me right here minus 184 plus, and that's going to be a negative 814, and then I'm going to take whatever the sum of that is. So let me just go ahead and actually get that sum. So when I get this quantity, that's going to be minus 998 minus, now I'm going to tackle this thing right here, that's going to be minus 364 plus 2 times negative 286, that's going to equal minus 572 look at that math. So that's going to equal minus 936. Okay, so that's the math. I'm going to do minus 998 minus a negative minus 936. So when I do that actual math, it's going to be plus positive. So it's going to be minus 998 plus 36. And so my answer here is going to be a negative 62 kilojoules per mole. That's what I get, assuming I didn't do any math problems, which you guys might find. So anyway, easy to do. Just understand what is being asked. If you're given a table that has heats of formation, know that you're going to have to use this equation right here. It'll be on your equation sheet. To use that, you're going to do your products minus your reactants. Know that N equals the number of moles, and the heat of formation is grabbed from your table. So I think these are actually quite doable, and you should be able to do it.